So I care about, oh, this is a 4-part question. Okay, so I want, okay, so number 4. A is asking us, I want the number of 3s electrons. I'm going to use E minus electrons in magnesium. B here is number of 3d electrons in, this is chromium, and C here is number of 4d electrons in yttrium, or in Y, and D here is number of OP. What's OP electrons here? I think it's asking us for, I'm looking at the answer, I think it's asking for 6p here. So let me say 6p in lead here. Okay, so let's look at the first one here. Number of 3s electrons in magnesium. I go all the way to magnesium here. I could write out my electron configuration for magnesium. So it'd be 1s2, 2s2, 2p6, and this here is 3s and then 2 here. So in this case here, I'm going to have 2 electrons here in my 3s orbital, right? So I want the number of 3s electrons in magnesium. This here, my answer here would be 2, right? This here would be 2, because you could think of magnesium having, this is 1s2, 2s2, 2p6, and then it's 3s2 here. And 3s2 is going to determine my number of electrons here is 2 here. So I'm going to have 2 electrons in my 3s orbital. In chromium, chromium is 24, number 24 here. So again, I can write out my electron configuration as well for chromium. So it'd be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then I would have 4s2 here, it would be here, and then I have 1, 2, 3, 4, right? So this would be a 3D 10 block, so this is 3D and 4. Which means my number of electrons here is going to be 4 electrons in my 3D block, right? So it's going to be 4 electrons here. So again, this is writing, this here says the number of electrons at 3s is 2, which is good. The number of chromium electrons is 5. Oh, they have 5 here, not 4. Why is that? 1, 2, 3, 4. It should be 4. 5 would be manganese here. So in the 3D block, it's actually, this solution here is incorrect. This here is actually a 4 here. Let's look at the other one here. So we have yttrium, which is Y here. That's all the way here. So I'm going to write down my electron configuration for this one here. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. This is 4p6, 5s2, and then we have 4d. And then 4D, my D, I want my 4D electrons. I have 4D here. This is simply just 1, right? So this here is the first electron here. So this is 4D1. So therefore, my electron here is simply just 1. Right? I have 1 4D electron in this case. In this case, they got the solution right here. And finally, in PB, PB is all the way down here. It's asking us the 6s2 electrons. I'm not going to write the configuration because it's pretty long here. But if I want the 6, this here is a 6p, oh sorry, this is a 6p orbital. Here, the p orbital starts again at, it starts at thallium here. So this is 1p, this is 2p, sorry, this is 2p, 3p, 4p, 5p, and this here is 6p, right? So 6p1, this here is 6p2, so therefore I have 2 6p electrons, right? So I have PB here is basically everything, and then it will have 6p and then 2 here, so which means I have 2 electrons in 6p, right? Thallium is 6p1, lead would be 6p2 here. So the solution here is correct, is partly correct. C here is, oh no, B is incorrect. And why did we say B was incorrect? Well, we said there's 4 electrons here, right? So the sorry. So I'm saying here the electron configuration of CR is as follows, and I'm going to write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d and 4. Therefore, there are 4 3d electrons. 3 electrons in Cr. So A, C, D are correct. So for this case, I'm just going to write it incorrect just so I can correct question. This is question B here. So I'm going to write incorrect here just to correct part B here.